Hello, Steve here. Welcome to our channel, Patio Heat, where we provide visual concepts of infrared heating as well as tips for ideal patio comfort. Check out our patioheat.com website for sales and more information. Please tap that like button if you find this video useful, as it helps others find our channel. Now let's get heating. Alright, so here we have this residential application. So we have this roof here that's got a sloped ceiling inside. We have a fan in the middle, and then also a doorway here that swings in. And there is a small overhang over here that will play a little bit of part of the application. Let's see if there's anything else. Let's go right into the dimensions. Overall dimensions I have here at 18.9 from outside edge to outside edge post, and then 15.3 on this side here to the outside edge and to the wall, and then over here from this little notched out area here I have at 13.3 to the outside edge. And then height wise, in here I have the ceiling height, and I don't have the ceiling finished off here. I'm not quite sure what the finish is going to be, but here I have at this is called 12 feet, but from the bottom here, this is a step up you can see here, but it might also be closer to this 11.11. That's fine. And 8'2" to the bottom edge of this support beam going across here. All right. Yeah, the fan is in the middle. I think this is about a 5-foot diameter fan. And all right. So I'm going to give you actually 4 different options on this particular plan, and you'll have to make a determination what best suits your needs. I have a dining table here in the middle. I'm not quite sure if it's going to be dining or reclining, but in any case, that's what I have. And it'll be similar as far as the footprint of heat, and you'll see that there's going to be a couple of different options that are going to cover up the whole area and then kind of cover up some of the area. Also, I should just mention that there will be one dimension that this is going to play a very particular point in this 18.9 one, I should say, option. Let's go ahead and turn that off again. Alright, so let's go ahead and put in 2 heaters. So if they were going to put one on this wall here, and then one, I just have it on the ceiling here, 6 inches away from this edge. This one here is also 6 inches away from this edge. You can see that I've used the OEM bracket. I'm going to have to put an extended bracket to get that 6 inch of clearance here met. So I think it's an extra 4 inches. Sorry about that. It's 4 inches that I will need. So the 4-inch longer bracket, I'll have to reconfirm that if you're going to do this plan. This one here is just attached to the ceiling and far enough away so where we get the 6 inches of clearance behind. And let's go ahead and look at those clearances. So here's the overall clearances on top of the heater. You can see that we're meeting those clearances with these locations. And then let's go ahead and look at the clearance below. So below with this angle I have here, so this angle here is roughly, I think, 25 degrees, and same over here. All right, and you can see with that 25 degrees I am missing the beam. Now wall mount, they do talk about this being an issue, so this is something you'll have to take in consideration, whether this actually meets your code or not. What the manufacturer states is that if you have a heater on the wall mounted and angled out at its maximum 60 degrees, you can use the OEM bracket on the wall. However, you need 12 inches above the heater. So this beam here I think is only 8, so if you're going to have it on here, we're going to hit that top edge here, so that might be an issue. Also, we have to make sure that we are not hitting the fan if this is a wooden fan blade. So alright, or a combustible fan blade, I should say. Alright, so we'll turn that off and look at the footprint of heat. So here you can see that we're covering the patio area, seating area that we have here, which is just 6 seating areas. And I think that's a fairly decent amount of coverage. You will be, I'm pretty sure, happy with that. You can see the crossover rays here in the middle are sufficient enough that you have heat from both sides to make this just about as equal as it would be on the outer edges of the seating area. So that would be option 1. So let's go ahead and turn that off. And then option 2 would be utilizing, and by the way, those were 6,000 watt units. This will be utilizing 4 of the 6,000 watt units in the exact same situation. We still need those extended brackets over here, and I have those mounted up here. Now the only difference is that we're not penetrating this beam here with the rays, so that's the only difference. Everything else would be the same, and we'll go ahead and look at the footprint of heat. Footprint of heat will be exactly identical, only that this will be a much more hotter spot here where you have especially, you know, these crossover rays around here. So you may want to really consider having a dimming system, or at least a duplex at the minimum, so that you can either turn the heaters on full 100%, you know, or 50% or 20% with a dimming system, or you can go with the duplex, which would turn one bulb on, one bulb off, and then you'd have to have a duplex for each independent unit. All right, let's go ahead and turn that off and go ahead and look at option 3. Option 3 would place the heaters here, so you're going to have to figure out a way to suspend this, maybe by mounting the bracket to the ceiling and then adding a extension piece of stainless, for instance, on this particular model, or if it's a black model that you get, you'll have to have it painted out. And then you know, this one here would have to, this bracket I should say, will have to be mounted on the ceiling, and then an extension piece between this bracket and this bracket to take up the space so we can keep this heater level. You have to have these level. If they're not level, then the nichrome wire inside will start to heat up, expand, and contract. As they expand, as they heat up, they expand. As they contract or cool, they contract, and then if they're at an angle, they start to slide downhill and then gather up and then cause a short, basically. So you need to keep this heater level at all times. All right, let's go ahead and look at the footprint of heat. Whoops, sorry about that. Here we go. And with the footprint of heat, you can see we're getting a pretty good coverage. I'm still missing a little bit in the center here. I have to keep a clearance. I should have mentioned this, you know, to this fan blade, and that's the issue with the fan. If it's combustible, I have to stay 18 inches from this edge to the edge, outside edge, or I guess you could call this the inside edge on this particular application, to the heater fan blade. And now you can drop the heater down a few inches from the fan. I don't know what the true height of the fan is, but if you drop the heater down so that the bottom edge of the heater is at or below the bottom edge of the fan blade, then you only need the 6 inches of clearance from that fan blade, which is depicted here, and you can move the heater a little bit closer on both sides, and then you can get a better crossover between the two. And you can see here with the heaters in this configuration that you get a nice footprint throughout the space here. We're probably missing about 2.5 feet on either side roughly, but this would also be a nice application. I just don't like this center here, but again, if you can lower the heater bottom edge to lower than the bottom edge of the fan, you can bring it up to the 6-inch clearance to the fan blade itself. All right. So that would be that, and then this would be the what I believe the customer actually asked for, and this is where those dimensions come in. Again, I've lowered this heater so that it is actually down to the bottom edge of the fan blade, the bottom edge of the heater here, and you can see that my 18 inches go past the fan blade, but we're not into that clearance area, so that's fine. But we are into the clearance area on this side here as well as this side here, so that would not function properly. So something like this, you'd have to bring the heater down to the bottom edge of this beam here across, and that would be the bottom edge of the heater's height. So they have to match up as far as the elevations. This edge, bottom to the bottom edge of this. And then you could place this heater in this fashion. However, I think that might be a little bit hotter than you'd want. So you definitely want a control system on something like this, and or possibly even using a 4,000 watt versus a 6,000 watt. Now, I believe this is in a very cold climate at times of the year, so I would think that a 6,000 would give you a better a better amount of heat that you're really looking for the really cold times. So let's go ahead and look at the footprint of heat. Let me turn off the clearances here. So with the configuration similar to this, now this heater, if it was to be placed in here, we would have to move them down. Let me just go ahead and do that right now. Let's do this here real quick, and it would have to be something like this here, and you can see now the footprint of heat is a little bit tighter. We're really missing the outer edges of the chairs. Not very happy about this. You can see here also that, you know, we're not really heating up the table center at all. So if this is the configuration that you plan on using this patio for, this would not be my ideal application. All right, well, I hope this has helped. If you're looking for some assistance with your outdoor heating application and you would like us to review your plans, please send your information to designs@patioheat.com. I'm Steve. Don't forget to hit that like button. It really helps us out to get our YouTube channel into that YouTube algorithm, and other people can help be helped by that. Thank you and have a great day.